Hello, friend. Uh, Shear force and bending moment. Simple problem. Here we can see that it is a simple problem. This problem is simple supported beams. Here we can see that it is a simple supported beam. Then two end is support. End A reactions R1 and end C the reactions R2. And this load at point B is 100 kg and another UDL load 200 kg per meter at a distance B to C is 3 meter span. So how can I find out the shear force diagram and bending moment diagram? Let's see. First of all, we find out the reactions, means what are the reactions R1 in upward directions and what are the reactions R2 in the upward directions. Then we can easily write here, then R1 plus R2 is equal to how much? R1 plus R2 is equal to 1000 kg plus 200 kg per meter into total meter is equal to 3. Then means this one is equal to how much? This one is equal to, we can see that is equal to 1600. That means 1600. So then it is equation number 1. Then we need to another equations to find out the R1 R2. So taking a moment about point A, then so taking a moment about point A, then taking a moment about point A is how much? So we have taken a moment about point A, means this point, this one. Then we can take a moment about point A. Then what is the value of R1, sorry, R2 into 6 minus of equal to 200 into 3 total load, and the distance equal to how much? This one, this distance is equal to 4.5. Why you will take this distance? Because of it is a load of UDL. If you have must be the taken distance at the middle of the span. So this the load of the UDL, these portions mean 3 meter. So what is the middle of this load? This means 1.5. That means 1.5 plus another distance from here is 3, means 3, then means 4.5. So that's how taken a 4.5 plus another load 1000 and distance equal to how much? Distance equal to 3. Then this value is equal to what? This value is equal to, if I calculate, and we get the value of 5700. Therefore R2 is equal to what? Then R2 is equal to 5700 divided by 6. Then after the solutions we get the value of R2. If we cancel it, then we get the value of 950. 950. Then we get the value of R2. Then putting the value of R2 in here, then we get the value of R1. Then what the value of R1? Then R1 equal to what? R1 is equal to 1600 minus 950 means what? Means how much? Means 650. 650. So we get the value of 650. 0. Then we can easily find out the R1 and R2. So R2, R1 we get, find the value of R1, R2. I think you understand how can I find out the R1 and R2. After the find out then R1 and R2, then value, find the value of SF and find the value of BM. Then draw the SF-BM diagrams. So first of all, find out the, then this one is deleted also, and this portion is deleted. Then it is the R1 is equal to 650, this one is equal to 950. Then for SF, SF at A, not A, actually C. SF at C is equal to what? SF at C is equal to plus 950. Then SF at C, then SF at B, not actually B. If we find out the this compound type of force when acting on the beam, so you have to find out the SF just before B. You have to write just SF, not a B actually, you have to write here just before B. Equal to how much? Plus 900 upward directions. Then this force, this means this UDL is equal to how much? 600 downward directions, then means 350. After that, SF at B, that means plus 3650 minus of this force, which is 1000. That means plus, sorry, minus 650. Minus 50. And again another point, SF at A is equal to how much? We have already found out the SF at A is equal to 650. So this value and this value must be equal but opposite. Then find out the BM. Let's see how can I find out the BM. How can I find out the value of VM? Just erase it and find the value of VM. Just find out the value of the BM. Now this one is equal to how much? This one is 650 and this one is a 950 again. So when to find out the value of BM, so BM at point C, BM at point C is equal to how much? BM at point C is equal to, already you have know that if any fixed point and find out the BM, then means bending moment is equal to 0, that BM at C is equal to 0. Then BM at B is equal to how much? So 950 upward directions, how much distance? This distance is this one, means into 3 plus again this force UDL, then how much? 6, total load 600 because of 200 kg per meter and 3 meters, that means 200 kg per meters and total 3 meters, that means 600 into how much distance? We have to take the distance from here to here, that means 1.5. So if it's calculated, then we can get the value of this ones. This 950 into 3 is equal to how much? Is 850, and 850, this one is equal to 850, 2850, and this one is equal to how much? This one is equal to 600. 600 into 1.5 is equal to how much? 900. The 900 plus 2850 is equal to what? 3750. That means this one is equal to 3750. So BM at B is equal to 3750. 3750. You have to remember your one, this value is equal to 350. Then again BM at A is equal to what? Then again BM is equal to 0. Because when you find out the BM at any point, then we get the value of 0. So here we can easily write BM at A equal to, you can write down the 0. So we have already find out the reactions, then find out the value of SF, then find out the value of BM. So now after that, putting this value and SFD and BMD. Now let's see how can I draw the SFD and BFD. It is a simple way to draw the SFD and BMD, and here we can easily see the how can I draw SFD and BMD in the loaded beam. Here you can easily understand the what force acting on the beam is much higher, where the bending moment is low, where the bending moment is maximum. So this is a figure. So if I, here you can see that the figures. So if I draw the SFD BMD, so this is the loaded beam. Then we can draw the straight line. Here we can draw the straight line A. So you can draw the line from the A point A. Here you can take a line from here, take a straight line. Again take a another straight line from C. You can take another straight line from C. Another straight line from the B. Draw just perpendicular line and the different point of the loaded beam. Then draw another reference line, say Control Z. So here, this one. Then take another coloring curve. So here you can see that what is the value of the BM at different point. I think you remember that all this thing. So what are the BM at point B? We have at point C. We have already find out BM at and BM. Sorry, SF at point C is equal to how much? SF at point C is equal to 950 because of reactions 950. So if we take any scale from here, so this line is take. So we take another perpendicular line from here. So take a color change, a straight line. So then we can take another line here. So 950, so how much distance from this one? This is take a scale, any scale, and take a distance from the 950. Again, what is the value of BM just before? Is 350. Just no force between the B and C, and draw this another line. Take here. Here and just before B, and another load in the B is equal to how much we have already find out, and 650. So just minus 650 means this portion is downward directions, minus 60. This value is equal to 950 plus, and here, sorry, UDL load, that means you have to draw here, this portion is this manners, sorry, not a straight line, just load is UDL load, so you have to draw this way, this way, the straight line actually. So you would draw a straight line. Then again load B is equal to how much? This is equal to 950. This portion is plus 350, but this portion is minus 650. Then again load how much is equal to this one is, so 650. So this diagram is SFD. This diagram is called the SFD. SFD. So you can draw a hatch line from this diagram. So you can easily see here. It's called the SFD. Again, draw a BMD from the loaded beam. How can I draw the draw BMD in the loaded diagram? So take another reference line from here. The reference line from here, and BM at C is equal to 0. BM at C is equal to 0, and BM at A is also 0. This point is also 0. Then here the BM, what is the value of the BM is 350. That means it is a UDL load, this portion. So you must draw the curve line. This way you have to draw the curve line, not a straight line. Because of UDL load, you have to draw the curve line. Means this way. Then again no load. Then again BM at A is equal to 0. Then again draw the straight line. This line is must be straight. This portion is must be straight because of no load. So this portion is curved line, and this is the straight line because of no load conditions. So I think it is the BMD, and this portion is called SFD. So this way we can easily draw the SFD and BMD diagram. So this portion you can here see that the SF sign change is plus to minus, means sign change from the negative positive to negative. So the BM, this portion is the maximum, and BM is always upward direction. That means BM is always positive. When you draw the simple supported beam in BM diagram, you must remember that it's always positive. But in cantilever is always negative. When you draw the cantilever beam, you can see that the BM is always negative. So it is the BMD and it is the SFD. I think you understand. And how can I draw the SFD and BMD in simple supported beams with compound loading? Also the different cases and solve, then we can easily understanding more when you solve the more problem, then you can easily understand how the SFD and BMD can be solved, and you can easily understand these portions is maximum bending moment, that's the chance of bending, this portion is chance probability is maximum, and these portions and this portion is the minimum. Also the shear force, this point and this point is the maximums. So thank you.